We love the romance of a lucky break. You've probably heard the stories. An irritated chef spitefully slices a potato too thin and invents the potato chip. Or a baker runs out of cocoa, tosses chopped chocolate into her dough, and accidentally creates the chocolate chip cookie. There is just one problem with these legendary blunders. They never actually happened. Cookbooks feature crispy fried potatoes decades before that chef allegedly lost his temper. And Ruth Wakefield, a trained home economist, explicitly stated she invented her famous cookie on purpose. She knew exactly what she was doing. Media culture relies heavily on the idea of catching lightning in a bottle. But when you examine the verifiable, historically documented accidents, a much more rigorous reality emerges. Every genuine, happy accident shares a specific structure. It starts with phase 1, the surprise, and requires an immediate transition into phase 2, the chase. Knowing this alters how we should evaluate our own missteps. Ruined projects and messy desks are unprompted experiments, where the most valuable data often hides in the spill. A mess is only useful if someone refuses to clean it up right away. The surprise demands a witness willing to ask why it happened. In 1956, engineer Wilson Greatbatch was building an oscillator to record heart sounds. He reached into a box and accidentally installed a 1 megohm resistor instead of the 10 kiloohm piece he needed. The circuit did something strange. It pulsed for 1.8 milliseconds, dropped to silence for a second, and pulsed again. He stared at the device and realized he was looking at the exact electrical cadence of a beating human heart. Over at Johns Hopkins in 1879, chemist Konstantin Fallberg was absorbed in his work with coal tar derivatives that he rushed to dinner without washing his hands. He broke off a piece of bread and found it tasted horribly sweet. He wiped his mouth, and his napkin tasted even sweeter. He traced the taste back to his unwashed thumb, and eventually to benzoic sulfamide, a zero-calorie compound we now call saccharin. Then there is Percy Spencer. In 1945, this self-taught Raytheon engineer was testing active radar tubes when he noticed a candy bar melting into a puddle in his pocket. Plenty of technicians had felt that warmth. Spencer decided to test it. He aimed the active magnetron directly at popcorn kernels and watched them burst across the lab, then tried an egg, which exploded in a coworker's face. The observation is what matters. The anomaly remains completely useless until a human stops to investigate it. But that initial spark is only half the equation. It is an invitation to do years of agonizing, deliberate engineering. Take Charles Goodyear. In 1839, he was trying to stop raw rubber from melting in the summer heat and cracking in the winter cold. During an argument, he dropped a glob of rubber mixed with sulfur onto a hot stove. It charred like leather, but the uncharred edges stayed firm, dry, and springy. He couldn't sell that glob. He spent the remainder of his family's fortune, landing in a debtor's prison, to work out the precise combination of heat, sulfur, and time required to vulcanize rubber. We see the same gap with Alexander Fleming. In 1928, the notoriously messy bacteriologist returned from a holiday to find a ruined Petri dish. A blob of blue-green mold had taken hold and completely dissolved the surrounding Staphylococcus bacteria. He called it penicillin, but he couldn't extract it in usable quantities. His colleagues ignored the discovery, and it sat untouched for over a decade. 10 years later, Howard Florey and Ernst Chain began the engineering work required to purify and mass-produce Fleming's mold on an industrial scale, just in time for World War II. The blunder fires the starting pistol. The relentless execution is the actual marathon. This formula applies far beyond the walls of a chemistry lab. It drives massive corporate pivots, too. In the 1950s, a Cincinnati company called Cudel was facing bankruptcy. They manufactured a pliable putty meant to roll coal soot off wallpaper. As households switched to cleaner oil and gas heating, nobody needed to clean soot off their walls anymore. The rescue came from a nursery school teacher. Looking for cheap craft materials, she handed the failing cleaning product to her students and noticed they absolutely adored squishing it into shapes. She urged Cudel's leadership to change course. They stripped out the detergent, added bright colors and an almond scent, and sold millions of units under a new name, Play-Doh. Over at Eastman Kodak, Harry Coover threw away a maddeningly sticky batch of cyanoacrylates twice, first in 1942, then again in 1951. before finally realizing his ruined gunsight plastic was actually a moisture-activated adhesive that needed no heat or pressure. He named it superglue. This requires us to view mistakes differently. True innovators treat melted candy bars, ruined bacterial cultures, and hopelessly stuck prisms as fresh data points. So the next time something goes wrong, don't immediately sweep up the mess. Look closely at what just happened. You might be holding the exact answer to a question you haven't even asked yet.